With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that the current in the inner loop varies according to I equals to 2t square. Then we need to find what is the current in the capacitor as a function of time. Okay, so this is our capacitor. Now here we can just consider that there would be a resistance in this circuit. Okay, so R and this inner radius of the circle would be equals to A, and outer radius of the circle would be equals to what? It would be equals to B. Okay, because there is always a this resistance with the capacitor. Now, if there is a current which is flowing here, so first of all, what we can do, we can just find what is the mutual inductance, okay, for our loop. So how can we find the value? Let us suppose that in this we are having a current I. So this current is different from this current. Let's say this is a current I, and here our A is very less than our B. That means this inside radius is very less than the outside radius. Okay. Now, if this is the case, we know that what would be the magnetic field at the center of this coil due to current I. We know that magnetic field at the center, this would be equals to mu naught I divided by twice of the radius. 2 times what is the radius? It is equals to B for this part. Okay. Now what would be the flux which would be linked with the smaller coil due to the magnetic field due to the current flowing in the bigger of the coil? So what is the flux which is linked with this coil? It would be equals to B into A, or we can say that mu naught I divided by 2B. And what is the value of area? Area value would be equals to pi into A square for this. Now, how to get the value of the mutual inductance? We know that M value would be equals to phi divided by I. Okay. So, the mutual inductance value, it would be equals to mu naught pi A square divided by 2B. Okay. This would be the value of mutual inductance. Now, if we find what is the this EMF which is induced into this coil, now we can easily find this value. How can we find this value? So, EMF, this would be equals to M times di divided by dt in the second coil. Okay, in the second, or we can say that second, or we can say that a smaller coil, a smaller coil. Now what is this EMF? This is a EMF which is induced in the bigger coil. Now the EMF which would be induced in the bigger coil, it would be due to the change in this, or we can say that the change in the current which is flowing through the smaller coil, that would be linked with the bigger coil. So what is the value of the mutual inductance? It is equals to mu naught pi A square divided by 2B. Now what would be the value of di by dt? Now this I is basically of the smaller coil. Okay, this we should remember. So we can say that it would be equals to 2 times of t. If we differentiate this, it would be 2, it is equals to 2t square. If we differentiate this, it would be 4t. So it would be equals to 4t. So we write the value as 4t. So the EMF which is induced in the bigger coil, it would be equals to 2 mu naught pi A square t divided by 2B. Now this is the EMF which would be induced. Now this EMF would be dropped in the capacitor as well as in the resistor. So we can say that this EB, this would be drop in the resistor. So potential drop in the resistor is IR, plus the potential drop in the capacitor would be Q divided by C. Now if we differentiate this expression, so we say that dE divided by dt, this would be equals to di divided by dt times the resistance plus dq divided by dt. Now dq divided by dt would be equals to I, so I divided by C. Now we can write the value of dE divided by dt. Now if we differentiate this, it would be equals to 2 mu naught pi A square divided by 2B, because differentiation of t would be equals to 1. Now if you put the values, so it would be 2, so we just write here itself, so 2 mu naught pi A square divided by B. This is the value of dE divided by dt. Now from this expression we can get the value of di over dt. So di over dt, this would be equals to, so we can just take all the terms to the other side, then it would turn out to be 2 mu naught pi A square C minus Bi divided by R B C. This would be the value of di by dt. Now what we can do, we can just bring this term to the to this side and dt to the other side, and we can simply integrate this to get the value of the current. So di, so we write di divided by dt, sorry, di divided by this term, 2 mu naught pi A square C minus Bi. This would be equals to dt divided by RBC. Now we can just integrate it from 0 to I, and the time limit would be from 0 to time t. Now if we differentiate this, it would turn out to be in logs. So it would be 2 mu naught pi a square c minus bi. Now if you put the limit as well as here, so it would be equals to, if you put the limit into this expression has to be 0 because upper limit is I, so it would be just same. So it would be 2 mu naught pi a square c. Now here there is a coefficient of minus b with I, so it would be divided by minus b. This would be equals to t divided by r b c. So we can see that this b and b would be gone. Now finally if we just solve this, then our I value would turn out to be 2 mu naught pi a square c divided by b 1 minus e to the power minus t divided by rc. This would be the final expression for our current. Okay, this would be the final expression for our current. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.